Alright, ladies and gentlemen, this is the fourth video where I'm going to review some facts about the Unit 4 test that you're going to take for my statistics class. And here we're going to look, we've finished up our correlation section where we talked about the coefficient of determination, the correlation coefficient, and the standard error of the estimate, and the y prime line. And now we're going to talk about chi-square distribution. We're going to look at these non-normal curves, and first of all, for this section, we are going to explain how to find confidence interval for this problem. So here we have a 90% confidence interval, which is going to be two-tail, for the variance and standard deviation of the lifetimes of these inexpensive cheap watches from a sample of 24 watches, and they had a standard deviation of a 4.8 month lifespan. So what I need to do is I need to get chi-squared left and chi-squared right. And to find chi-squared left and chi-squared right, you'll need your chi-squared chart or table that came with your book or the class. And what you're going to do is you're going to look up 23 degrees of freedom for chi-squared left and chi-squared right, because the degrees of freedom is n minus 1. Now, just coming off the scatter plot chapter with the r values, you were used to n minus 2, but this is going to be n minus 1 in this section. Now, our alpha in this case, since our confidence interval was 90%, our alpha is 10%, which means that for a two-tail test, we have to have our alpha divided by 2. So for chi-squared left, we're going to look up 95%. And at that moment, at 23 degrees of freedom, looking up 0.95 or 95%, or 0.9500, depending on how your chart or table is drawn, this would be chi-squared left of 13 and 91 thousandths. Now, chi-squared right, you're going to look up 0.0500 or 5%, and chi-squared right is going to be 35 and 172 thousandths. Now, the formula that we're going to use is to take our degrees of freedom, multiply that by our standard deviation, which was given to us in the problem, squared, divided by chi-squared right. Chi-squared right is going to be on the left of this formula, and that's going to be less than the variation, which is less than the other side of the equation, which is the same sample size, degrees of freedom. I said sample size, but I meant degrees of freedom, times the standard deviation squared, divided by chi-squared left. And a big reason why the chi-squared right is on the left and the chi-squared left is on the right is the chi-squared right is bigger, and this will give us a smaller number, and the smaller number has to be less than, or at the bottom of our estimate for the variation. So this gives us 15.07 is on the low end, and on the high end is going to be 40.48. That's going to be the variation. I'm 90% confident that the variation is going to be between 15 and 40 months, but I really want to take the square root of this to get us to the standard deviation. So we can say with 90% certainty that 66% of the watches, or an average, that's a rough approximation of one standard deviation above or below the norm, is going to be between a failure rate between 3.88 and, that's taking the square root of this, and 6.36 months in terms of the cheap watches' failure rates. So what this means is we are 90% sure that the standard deviation of the watch's lifespan is between 3.88 and 6.36 months. Now, this doesn't actually give us the actual failure rate of these watches, But we know that if these watches, if we were ever given the average, if we were given the average was like they lasted for 5 years or 10 years or 1 year, then they would be, give or take 4 to 6 months, from that average. None of this talks about an average, so make sure you don't ever mention the average, even if I slipped up and did that in the video. This doesn't talk about an average. It just says that the watches fail with a standard deviation of 4.8 months from their failure date. So we can say within 90% confidence that the failure rate of these watches will be 4 to 6 months from their average failure date, which again is not mentioned in this problem. But it goes to show that these watches are somewhat consistent. Hopefully they'll last multiple years for you, but they are inexpensive watches. Now what we're going to do is look at these percentage rates of vacation home ownership, and some randomly selected states are below. So how much do people own vacation homes? And we want to be 99% confident that the standard deviation is going to be within this interval. Now we can figure out the average actually by doing an average of this, but by running this into the calculator, we can get a standard deviation of 4 44/100ths. Now that's if we plug this into list 1 and we did the one variable stats. I'm not going to go through that since that was really done elaborately last chapter and the one before it. Units 2 and 3 really went through finding standard deviations on the calculator, and we would use the S of X on the calculator, one variable stat, because there's less than 30 pieces of data here. Okay, so we have that. Our error is going to be 1%, but since this is a two-tailed test, we've got to divide it by 2. So this is going to be looking up 0.005 on the right and 99 or 0.9950 on the left. So let's get our chi-squared left, which is looking up again 0.9950 or 99.5%, depending on how your table writes it, and this gives us 0.989. And chi-squared right is we're going to look up 0.0050 or 0.5%, half a percent. This is going to give us 20.278. Our degrees of freedom in this case is going to be 7 because we have got 1, 2, 3, 4, 5, 6, 7, 8 pieces of data, and one fewer than that is 7. So this is going to give us the formula for our confidence interval for the variance as 7 times 4.44 squared divided by chi-squared right, 20.278, which is less than the variance, which is less than degrees of freedom times the standard deviation squared that we found by typing it into the calculator, divided by chi-squared left, 0.989. And we put chi-squared right on this side because this will give us the smaller number on the left, which is 6.81. So the variance is going to be 6.81% on the low end, and on the high end 139.53%. But let's take the square root so we can talk about this a little bit more logical in the terms of its standard deviation. 2.61 to 11.81. What this means, and you can't see that because that question got cut off at the bottom of this, it says, what does this mean? It means we are 99% sure, which is, and by being 99% sure, that gives us a pretty wide gap here. We are 99% sure that the standard deviation, oh, I forgot to write the word sure. There we go. We are 99% sure that the standard deviation of the percentage of vacation home ownership, VACATION, vacation home ownership, will be between 2.61 and 11.81%. So we can find the average of these, 8 places and say, well, we're 99% sure that the standard deviation is going to be between 2 and 11. But 2 and 11, I mean, that's a pretty wide gap. I mean, if you were polling for an election or something like that and you were off by 11 points or percentage points, that'd be a pretty wide margin of error, so to speak. So due to the sample size and the variation of this data and our desire to be 99% confident, this gives us a pretty big width for our standard deviation. All right, thank you for watching.